In one of my previous videos, we went over the square root of I, and we found out that it is plus minus 1 over root 2 plus minus 1 over root 2I. But I've always wondered, what's I to the power I? It was sort of hard to wrap my head around this, so I decided to compute it. In my previous video, we went over, or I guess we used, converting complex numbers to exponential form. But I'd not really go into depth about that. So this is my chance. Say we have a complex number z. We can write this in exponential form, which is r times e to the power I theta. Well, what are all these symbols? Z is a complex number. R is the magnitude of the complex number. Magnitude. E is 2.718, etc. I is the square root of -1. And theta is the angle between the x-axis and the magnitude. The magnitude line, I should say. Magnitude line. And this might be a bit hard to wrap your head around, so I'll draw a graph. I'll call this 1, I, -1, and -I. I'll also pick an arbitrary complex number over here, call it z, and I'll draw the magnitude because we're going to need that. This is r. And here's my angle. I'll do this in a different color, possibly red. Here's my angle, theta. So here's all of our information. Our angle theta, our r, and the complex number z. Now, how does this apply to finding I to the power I? Well, what if we wrote the complex number I in exponential form? So I is equal to r times e to the power I theta. Well, what's r? What's the magnitude of I? Well, here's I, here's 0. Looks like the magnitude's 1, right? And how do we just make sure? I squared, or I guess the absolute value of I squared is the absolute value of -1, which is 1. So I is equal to 1 times e to the power I theta. What's theta? Well, we want to go from the x-axis, or I guess the real axis. I'll just jot down the real axis and imaginary axis. We want to go to the real axis to the imaginary axis, and do this in a different color. This is just a 90-degree angle, meaning theta is just pi over 2. This means we can simplify this to I is equal to 1 times e to the power I pi over 2. Now we have all of our information. Okay, now we found what I is, and we want to raise it to the power I. So let's just raise both sides to the power I. 1 times e to the power I pi over 2, all to the power I. And using our exponential properties, we have I to the power I is equal to e to the power I squared times pi over 2. Wait, but I squared is -1, so e to the power -1, or negative pi over 2. Hold on. This is a real number. This is an imaginary number raised to an imaginary number. That's insane. But that's not the most insane thing. I'll just erase this a bit, because the most insane thing is that there's more than one value. How? That doesn't make any sense. Well, the thing is, theta is any angle at all. Theta is a part of all real numbers. So this means that if I just added 2 pi to whatever theta is, theta plus 2 pi, the angle technically remains the same, as long as the angle is in between 0 and 2 pi. Adding 2 pi to it won't do anything. I to the I is part of the set of all real numbers. We found two amazing things about I to the power I. One, it's a real number. It's a real number. Two, there are multiple solutions, or I guess answers.